We are solving a NEET 2021 question in oscillatory motion. The problem is like this. A body is executing a simple harmonic motion with frequency n. What is the frequency of the potential energy is? So you can solve this in two ways. First, I will solve in a method 1, easy method. And I will also explain the mathematical way of understanding that. We know that whenever a particle is in simple harmonic motion, it has such a number of the times goes and comes back to its main position. That's called its frequency. Let that frequency is n. So what do you mean by an oscillatory motion is there is a main position, extreme position, interim position. Here the displacement is 0. Here the displacement is maximum. Here the displacement is maximum on the other side. We can write equations for potential energy as half k x square. So we can see when the body is in oscillatory motion, it goes this way. So here potential energy becomes maximum. Again it comes back and goes to here, and here also again potential energy becomes maximum. So what we can notice is in one oscillation potential energy becomes maximum twice. That implies frequency of potential energy is also twice the original frequency. Original frequency is n, so the potential energy frequency is 2n. That is the same in the case of kinetic energy also, because kinetic energy also becomes maximum twice in one oscillatory motion. That's theoretical way of solving it. I can solve it in other way, mathematical way. I can explain the same using a mathematical way. I will do that also for the sake of your convenience. So what it says, when a particle is in simple harmonic motion, its displacement can be expressed as y equal to a sine omega t. That is a sine omega is 2 pi times of n into t, where n is its frequency. N is its frequency. But if you write an equation for potential energy, as I told you, of k x square, k is force constant, x is this much, a sine omega t whole square. That is half k a square sine square omega t. But we can express this as, we can see sine square theta can be expressed as 1 minus cos 2 theta by 2. We can express it this way. That implies potential energy can also be expressed as half k a square of, in the place of sine square omega t, we can rewrite that as sine square omega t. We can write 1 minus cos 2 times of omega t. Cos 2 theta is there, na? 2 times of omega t, of course, by 2, and t is there. Omega t sine omega t form. Now what we can notice is, again in the place of this omega also, I can write half k a square 1 minus cos 2. In the place of omega also, I can write 2 pi n into t. As I have written t outside, I did not write here t. So if you notice, here in the place of frequency I have n, but here in the place of frequency I have not only n, but there is a 2 extra. So this 2 into n becomes 2n. This 2 pi is common here as well as here. So what we can say is, that implies frequency of potential energy is twice the original frequency of the displacement of an oscillatory motion. That's how we can prove that. That's how we get the answer, same answer in both the cases, 2n. That's it. And thank you for watching.